Welcome. Today we're going to be talking about Lesson 4.8, the line of best fit. You can see our objectives for the lesson are on your screen. Go ahead and jot down in shorthand. Line of best fit for a set of linear data. So we're going to be using our calculator, inputting our lists, list 1 and list 2 again, and then going into the linear regression and coming up with that line of best fit. We're going to determine and interpret the correlation coefficient, and that's all on the calculator. Go ahead and jot down your vocabulary: residual, least squares line, line of best fit, linear regression, and correlation coefficient. We'll be working on those definitions. A residual is the signed vertical distance between a data point and a line of fit. Now by signed we mean positive or negative. So below the line we'll have a negative sign, above we'll have positive. The least squares line for data set is a line of fit for which the sum of the squares of the residuals is as small as possible. And that's the first activity that we'll be working on. A line of best fit is the line that comes closest to all of the points in the data set using the given process that we're going to be learning, both on paper and on the calculator. And our linear regression is a process of finding the least squares line. We're going to be talking about a correlation coefficient. So as we're looking at this paragraph here, please jot down your version of the definition. It says this is our number R. We did find this with the calculator before, you might remember, but we're going to have a review today. R is always in between -1 and 1. It's describing how closely the points in a scatter plot cluster around the line of best fit. So let's refresh our memories on this. A correlation coefficient of -1 indicates practically perfect fit of the data to our line, and the slope is negative. And conversely, a correlation coefficient of +1 indicates almost a perfect fit with a positive slope. By using the squares of residuals, positive and negative residuals don't cancel out because we are squaring them. All squares are positive. So let's look at how this is going to work. We have a set of data, 4 ordered pairs. We're going to plot those, and we're going to try to figure out which of these lines is the best fit for the data. So let's go ahead and look at our graph. You see all 4 points are plotted. The line y equals 2x plus 2 is our blue line, y-intercept 2, slope of 2, and our line y equals x plus 4, y-intercept 4, slope of 1. So the way that we're going to find our residuals is this. We're going to take the distance from the point to the line. Let's go with I think they go with x plus 4 first. Yep. So we're going to take the distance from the point, 1, 7, to our line. You see we're just counting on the grid. That's 2 above. Next point is 1 below, the other 1 below, and 1 above. We're going to square those values. That's why it's called the sum of squared residuals. And we're going to add those up. This sum is what we're interested in. We're going to compare it to the other one, and the lowest sum will be the better fit. So here's our other line. We're going to take the distance from each point to the line, take those sums of squares, and add them up. And we can see we get a sum of 15 this time. The first line was 7, so we can defiantly say, no, not defiantly, we could definitely say that the line y equals x plus 4 is the better fit. It's got the lower residual. Let's check it out, example 1. We have 2 lines for this data. -1/2 x plus 6 and -x plus 8. We're going to plot the data and compare the residuals. They're going to go with the -1/2 x plus 6 first. No. And here we go again. We just had a little minor interruption. Rude children from Anchor Point are trying to get in the room, and Tyson Schaefer was the name. So if you see him, go ahead and sock him in the arm. So you guys, we take the first line, distance -2, positive 2, negative 2, positive 2. We take the sum of those squares, add them up to get 16. Let's take the second line. We see the residuals of negative 3, 2, negative 1, and 4. Adding those squares together, we see 30. Comparing the 16 to 30, we can see that the first residual is the better fit. The table shows populations and numbers of U.S. reps for several states in the year 2000. Notice Alaska, number 2, population in millions, 0.6. We have 600,000 people roughly, and we have 1 representative. We're going to find the equation for the line of best fit. Now stop on this slide for just a minute. These are the steps to entering the data and calculating the linear regression. So one tip that I want to tell you right here, as we're inputting data into our 2 lists, list 1 and list 2, to do our linear regression, before you do that, I need you to go to the mode window. You're going to come down to stat diagnostics, and you need to turn those on. Otherwise, you will not see your R value or your regression factor. So let's go ahead, take notes, or come back to this window and go through these steps for the next activity that we're going to do. So here's your data. The table shows the prices and the lengths in yards of several balls of yarn at the Knit Mart. So length, 1,680 yards, $65. We're going to find an equation for the line of best fit. That means we're going to input the data into list 1 and list 2. If you need to go back to your screen to find the steps, we hit the stat button and edit, and it took us to this window. You're going to input your data just like this. Before you do that, remember we always put the dependent variable in list 2. So list 1 is our independent, or X. List 2 is our dependent, or Y value. So as you input that data, we go back to calculate the linear regression that was on your window that we just saw, and you can see our line of best fit has a slope A, the number next to X. Our coefficient is 0.04, and our B value, or y-intercept, is roughly 6.4. So we're going to probably interpret those in just a minute. The meaning of the slope and the y-intercept. The slope tells us it's about 4 cents per yard, and the y-intercept tells us that it's $6.38 is added to the cost of every ball, because that X value would be 0. The average cost of 1,000 yards would be roughly $46.38. Now the R values, this is where I told you to hit the mode button on your calculator, go down to stats diagnostic and turn that on. The R value closest to 1 or negative 1 indicates a very strong correlation. The closer R is to 0, the weaker the correlation. This table is showing the relationship between points allowed and games won by a football team over 8 seasons. Find the equation for a line of best fit, and then tell me how well it fits. So we're going to use our calculator, enter the data from list 1 and list 2. We press stat, choose calc, and choose the linear regression. It's option 4, and press enter. When you see this window, you get your regression equation again. You get a slope of negative 0.02. Our y-intercept is roughly 10, and we see our R value. This is the one we're interested in right now. This is very close to negative 1. Therefore, it is a very good representation of the data, meaning the regression factor is close and tight, and the slope will come out negative. You guys check it out. Number 3, Kylie and Marcus, designing a quiz to measure how much information adults retain after leaving school. The table shows the quiz scores of several adults and matches the number of years each person has out of school. Find the equation for a line of best fit and tell us how well that represents the data. Go ahead and do all those steps again with this data, and we'll check your answer. So you should have come up with a window very closely resembling this one. Your linear regression should have given you the results negative 2.7 for a slope and 84 for a y-intercept. And we've got an R value of negative 0.88, which is roughly 0.9. It's got a good correlation. The line is closely fit to the data. But if you remember our last one, negative 0.9, it's a little weaker than that, but it's still a strong correlation. Example 4 says, additional, Malik is a contractor installing windows. The table shows data for his first 8 weeks on the job, and it shows the equation of least squares line for the data and the R value. Discuss the correlation and causation for the data set. So we know by the R value there's a strong correlation. The cause and effect relationship, likely the less installation time, contributes to a greater profit per hour. So these are the things that we want to be thinking about as we interpret data, look at it, and try to come up with an understanding. This one says 8 adults were surveyed about their education and earnings. The table shows the survey results. The equation of the least squares line for the data is positive 5.59 x minus 30, and the R value is 0.86. There's a strong positive correlation, and the cause and effect, possibly the more education, often contributes to higher earnings. Not necessarily so all the time. I'd like you to take a look at these quiz questions and come back and check your answers. So for question 1, part 1, it says 2 lines of fit would be these two. Plot the data and figure out the residuals. You should have come up with 18, the sum of the squares for the first line, 20, the sum of the squares for the second line. So our first line, negative x plus 11, would be a better fit. Find an equation for the line of best fit. That means we're going to input the data and use the calculator to come up with the linear regression. Part 2 says find the equation for a line of best fit and interpret the meaning of the slope, the y-intercept, and the R value. Use your equation to predict the number of incorrect answers for 5 hours of study. So what you should have come up with the calculator is a negative 0.8 slope, y-intercept of 10.3. And our slope would indicate to us that for every hour of study, the number of incorrect answers decreases by 0.8. The y-intercept would correlate to an x value of 0, which would be 0 hours of studying. And they should get, with the prediction, 10.3 incorrect answers. Part 3, how well does the line of best fit represent the data? We got an R value of negative 0.79, which is fairly well. It's not as strong as the other ones we've seen, but there is a correlation, and the slope is negative.